Hi everyone, this is V. Srinivasa, Assistant Professor of Mathematics, working in Mlritm. So this is my second video. In the first video, already I explained about double integrals. So these double integrals or triple integrals, these are the topics in multiple integrals. This is useful for first year BTech students. So here double integrals, evaluation of double integrals, and triple integrals, evaluation of triple integrals, that I have to cover in coming videos also. So today I will discuss about double integrals without taking the limits, how to evaluate the double integrals. Without giving, suppose limits are given, we can easily find the double integrals. So limits are not given, region is given, then how to evaluate the double integrals we will discuss in this session. So suppose limits evaluation is three types. So limits are given, both are constants. We can do any manner, first x and then y, or first y and then x. One and the second way is y in terms of x constants. Then first we have to integrate with respect to y and then with respect to x. So while doing with respect to y, keeping x terms are constants, and then integrate with respect to x within the given limits. Finally, we get some answer. That is second type. And the third type is x in terms of y and y constants. So at that time, first we have to integrate with respect to x, keeping y terms constant, and then integrate with respect to y within the given limits. Then we get the answer. These are three ways of evaluating double integrals. Already these three ways I covered in last video. So in these three ways, if the limits are given, we can easily identify which we have to do first. That is first with respect to x or y, we can easily identify. Suppose limits are not given, so some region, we have to integrate over some region. Then how to do the double integral evaluation, that we will discuss now. So here I want to explain a single one problem when the limits are not given. So this is evaluate integral double integral xy x plus y dx dy over the region R bounded by y is equal to x square and y is equal to x. This is the given problem. So here it's very clear to say that it is a double integral and limits are not given, and that limits taken from the given region. The region is bounded by y is equal to x square and y is equal to x. For this type of problems, first we have to draw a rough sketch. From that figure only we have to extract the limits. So here in order to draw the diagram, the student must have the basic knowledge of coordinate geometry. So here y is equal to x square. Y is equal to x square represents what? And y is equal to x. Y is equal to x represents what? So simply we know that y is equal to x represents a line. And y is equal to x square is nothing but x square is equal to y, that represents a parabola. So that's what first we have to draw, one parabola and one line. So this is first I am taking coordinate axis, that is x axis and y axis. So in this y is equal to x square is nothing but x square is equal to y. Here we have the students, most of the students have the confusion how to draw x square is equal to y and y square is equal to x. Simple way, x even terms we can draw the parabola in y direction. If y even terms, we will draw the parabola in x direction. So x square is equal to y means x even terms. X even terms means the parabola is drawn in y direction. Y direction is nothing but vertically we have to draw. This is the parabola y is equal to x square. And the line y is equal to mx. Y is equal to x. Y is equal to x is nothing but y is equal to mx, slope is 1. So we can draw the line y is equal to x. This is y is equal to x. So in this region we have to integrate. So we know this is the origin 0, 0. This is the point of intersection of y is equal to x and y is equal to x square. This very simple. We have to find out what is the point of intersection of y is equal to x and y is equal to x square. So here one point is 0, 0. Now tell me here y is equal to x, y is equal to x square. What are the points satisfies these two conditions? Only 2 points. One is 0. 0 is equal to 0, 0 is equal to 0 square. Another one is 1. 1 is equal to 1, 1 is equal to 1 square. So this is a point of intersection 1, 1. So 0, 0 to 1, 1. In this region we have to integrate. Okay, from this we can find the limits. So here let I is equal to given integral x y. I am multiplying this x into x square y plus xy into y xy square into dx dy. That is a given integral. Now here in this given integral we have to write the y limits and x limits. The simple way already I explained, y in terms of x constants, or else x in terms of y constants. Simply here this lower R gives lower limit, upper R gives upper limit. So lower arc represents y is equal to x square. So that y limits are x square to, and upper arc represents y is equal to x. So y limits are x square to x, that is y in terms of x. Then automatically x should be constants. So what are the x limits? X limits means we will see horizontally 0 to 1. X limits are 0 to 1. So this is a way of finding limits from the given region of integration. First we have to draw the rough sketch of the given region. From that region we have to find the limits. Then as usually we can proceed for evaluating the double integral. So here first what I am doing? First I am doing with respect to y. That's what here dy first to dx next. So with respect to y, keeping x terms constant, and then the resultant should be integrated with respect to x within the given limits, constant limits. So that is equal to integral 0 to 1 first with respect to y. So x square is constant. Integral of y square by 2 plus x into integral of y square, y cube by 3, limits x square to x dx. So here apply the upper minus lower limits. That is equal to, when I apply the upper and lower limits, integral 0 to 1, in place of y we have to substitute the limits. First upper limit is x, lower limit is x square. When I substitute upper limit, in place of y x, so x square into x square, x power 4 by 2 plus so in place of y cube, if I substitute in place of y, if I substitute x, so that is x cube, already x is there, x into x cube, x power 4 by 3. This is upper limit minus lower limit. So lower limit in place of y, if I substitute x square, first term already x square is there, x square whole square, x power 4, x square into x power 4, x power 6 by 2, plus in the second term when I substitute in place of y x square whole cube, x power 6 into x power 7 by 3, whole bracket dx. This we got. So that is integral 0 to 1, this is x power 4 by 2 plus x power 4 by 3. So here the 6 is LCM. When 6 is LCM, then 3 times 3x power 4 plus 2x power 4, 5x power 4 by 6. This is 5x power 4 by 6. That is the first term. When I take 6 is LCM, 3 times 3x power 4 plus 2 times 5x power 4 minus x power 6 by 2 plus minus x power 7 by 3. So x power 7 by 3. within the limit dx. Now it is the time for integrating with respect to x. Y limits completed. Now we have to integrate with respect to x. So here we know x power n formula. I am applying repeatedly x power n or y power n formula. So here 5 by 6 is constant. Integral of x power 4, x power 5 by 5. X power 5 by 5. That is the first term. Minus 1 by 2 is constant. Integral of x power 6, x power 7 by 7. X power 7 by 7. That is the second term. Minus integral of x power 7, x power 8 by, already 3 is there, 8 3s are 24. Whole bracket within the limits 0 to 1. Now we have to apply upper limit 1, lower limit 0. So when I apply upper limit 1, this is 5 cancel. This answer is 1 power 5 is 1, 1 by 6. First term is 1 by 6. And second term minus, so when I substitute x value 1, 1 by 7 2s are 14. 1 by 14 minus 1 by 24. 1 by 24. This is upper limit. And lower limit 0. So we can leave it. So this is 1 by 6, 1 by 24 minus 1 by 14. So when we simplify this, we get some answer. That is the final answer. Right. This is the way of doing double integral. So here double integral of xy into x plus y. Once again I will explain. X, so the given integrand is xy into x plus y. So I am simplifying this x into x, x square into y, xy into y, xy square, dy dx. The way of taking limit is very important. I explained very clearly how to take the limits from the given region of integration. The given region is y is equal to x square, bounded by the y is equal to x square and y is equal to x. That means the region is bounded by one parabola that is equal to, represented by x square is equal to y, which can be drawn on vertically, and y is equal to x. It's a straight line, passes through origin. Definitely they will intersect at 2 points. One point is 0, 0 and second point is 1, 1. So here that means very clear to say that y expressed in terms of x and x, y in terms of x and x constants. What about y limits? Y limits are y is equal to x square lower limit to y is equal to x upper limit. Y limits are x square to x and x limits are constants. Always one is in terms of variable, another one is automatically constant. So that is 0 to 1 constants. That's what here first I can start with the integration with respect to y, x keeping x terms constant, x square constant, integral of y square by 2 plus x constant, integral of y square y cube by 3, limits x square to x. Lower limit x square, because lower arc is y is equal to x square, upper limit x. So when I substitute in place of y, upper limit first, in place of y x square, already x square is there, x square into x square, x power 4 by 2 plus, when I substitute upper limit in the second term, x into x cube, x power 4 by 3 minus, lower limit when I substitute in place of x square whole square, x power 4, x power 4 into x square, x power 6 by 2 plus, in the second term also x square whole cube, x power 6, x power 6 into x power 7 by 3 dx. So here x power 4 by 2 plus x power 4 by 3. So I am combining these two terms. Here 6 is LCM, 3 times 3x power 4, 2 times 2x power 4, 5x power 4 by 6. Coming to the lower limit, minus upper minus lower, minus x power 6 by 2 minus x power 7 by 3. So then when apply the second time integration, that is with respect to x, 5 by 6 constant, integral of x power 4 is x power 5 by 5 minus integral 1 by 2 constant, integral of x power 6, x power 6 is x power 7 by 7 minus 1 by 3 already constant, x power 7 integration x power 8 by 8, 8 into 3 24. So when I substitute upper limit, this is upper limit in place of x 1 by 6 minus 1 by 6 minus, this is 1 by x power 7, 1 power 7, 1 by 14 minus 1 by 24. Lower limit it is 0. Lower limit is 0. So this is the answer. So this is the way of calculating evaluating double integrals.